All right, to start off question 11, we're going to have to remember an exponent rule to be able to rewrite this stuff. So the most common one that you guys use is when you multiply things with the same base, you add the exponents, which is why x times x is x squared. But if you were to divide something with the same base, then you subtract the exponents. So a lot of the times I would describe this as saying like x squared cancels out two of these and leaves a 1. But another way to think of that with the property is like this. You divide things with the same base, you subtract the exponents. So I say all that because you need to split up these r's and s's somehow. So if I compare this, where the exponents are being subtracted, to this, and I'm trying to go this direction, this would be like e to the r over e to the 2s. So normally we don't go that direction with the property, but we need to for this one. Okay, next up we need to separate our variables. So let's divide both sides by e to the r and multiply both sides by ds. That will get all the r stuff on the left, all the s stuff on the right. And I'm actually going to rewrite this like so. I just prefer to deal with that a little bit more. Okay, now that the variables have been separated, the integration should be quite a bit easier here. So you could do u substitution on both of these. I think maybe on the left it's probably easy enough you don't need u substitution. So e to the negative r is going to give you an e to the negative r, but if you take the derivative of this, you're going to get a times 1 because of the chain rule, the derivative of the inside. But you want this guy to be positive, so you have to put a negative out front. So if that's too much for you to juggle in your head, then go ahead and do u substitution and pick u to be negative r. So same thing over here. You really could just multiply by negative 1/2, like so. But if you have a hard time undoing that one step of u substitution in your head, then just sidebar over here, pick out your u, find your du, compare what you have to what you want, and then you can rewrite the question as e to the u times negative 1/2 du, and the derivative of e to the u is e to the u. And so notice, oops, same thing, but just a different option. U substitution is always going to work. So I know it's a pain to write out a couple more steps, but sometimes it ends up being faster than trying to juggle it in your head. But if it's only one or two tiny steps of undoing chain rule, I guess if you do practice it sometimes, then it does get easier. Okay, and since this is dr ds, I guess there's a chance we could have to solve this for r. So I'll call this guy C1. So to solve this for r, maybe I will multiply both sides by negative 1. And then an unknown number times negative 1 is just a different unknown number. No need to call it negative C1. We don't need to be that specific. And then here, this is a very common step that you guys are not used to having to do algebraically. But we could, well, if I'm trying to solve for r, I guess I could take the natural log of both sides. Because one property of natural logs is if you have an exponent on something that you're taking the log of, this can all come down out front. Makes the right side kind of messy, but that's okay. It's just a big number. Well, I guess it has an S too, but I'm solving it for r equals, so I don't really care how messy the other side gets. You need to remember that the natural log of e is 1. That's a very basic property that you will need to know. So from here, looks like we're just about done. Multiply both sides by -1. And since this is my final answer, you don't need to call it C1, C2, C3. Just make your final answer just a plain LC. So you could potentially stop all the way up here, depending on the question. Free response, they typically want you to solve for y equals or r equals, so you have to keep going. And in multiple choice, sometimes you stop here, sometimes you might be able to stop here, or here, or here, or here. So you got to practice being able to go all the way down just in case for those type of questions.